Hello, everyone. This is the lecture for section 3.3, trigonometric substitution. So in this section, we're going to be handling specific types of integrals, specifically integrals that have these sort of terms in them. This one, or this one. Okay. Trigonometric substitution is really just for lack of a better term, spicy U substitution. Okay. We're just going to be using a lot of our trig identities to sort of work around some of the harder terms, these in particular, like I said, these. Okay. So let me get started by sort of associating each term with sort of like the method or the technique that we're going to use. Okay. So if you see anything that looks like this, the associated trig identity that we're going to be using is this one, the sine squared plus cosine squared is equal to 1. Okay. And the substitution that we're going to have to do is this right here. Let x equal a sine theta. Okay. If you have anything that looks like this, right, we're going to be using this one, which means we let x equal a tangent theta. Okay. And if we have anything that looks like this, we need that identity, and we're going to let x equal a secant theta. Okay. So we're getting into, since this is chapter 3, right? Chapter 3 deals with all these various integration techniques. Okay, so these are all sort of processes, strategies that you have under your sleeve that you can use with any integral that you sort of run across. Okay, this one right here, trigonometric substitution, is usually pretty long. So if you have to whip this out for an integral, then that meant that this one's going to take you a little while. Okay, and you'll see what I mean in a second. These trigonometric substitution ones, they're innately long. Okay, and you got to keep track of a lot of stuff. So don't hesitate to sort of write all the work out. You're going to have a lot of sort of side work that you have to do. So just keep track of everything. Okay, so the first one I'm going to cover is integrals that involve that a squared minus x squared. Okay, these kind right here. Okay, and if you remember from the table above it, I need to let x equal a sine theta. Okay, so let's go ahead and get started on this one in particular. Okay, so let's say I wanted to find this integral, right? I'm going to have to do a rewrite really quick, and that's exactly what I'm going to do right now. So integral 1 over, the x is going to stay there, but I want to do this, the square root of the square root of 6 squared minus x squared. So the reason why is because if you take a look at my thing here, right, I need something squared, right? So if I take that 6 and do square root of 6 squared, right, that sort of solves everything, right? So now that we have it written out like this, right, now it gives us our substitution. So the proper way of doing this, right, is going to be where we let x equal the square root of 6 sine of theta. Okay. And this is still dx. Let me put that down, right? So we still need to do dx on this side. Dx is equal to, let me make this a little smaller. I'm going to run out of space here. So x is equal to root 6 sine of theta. Dx is going to be square root of 6 cosine of theta d theta. Okay, so now at this point, it's going to be a lot of substitution and just algebraic and trigonometric manipulation to simplify this down to something much nicer. Okay, so like I said, keep track of everything. So this is now going to be the integral, okay, of 1 divided by x, which is square root of 6 sine theta, oops, sine theta, okay, square root. I'm just going to go ahead and plug it in, and I'm not going to reduce anything yet so that everybody can see sort of all of it in all its glory. Square root of 6 squared minus square root of 6 sine theta, and I need this to go a little farther, but I'm going to make that squared first. Okay, like I said, these are long, right? And now I have a times dx. We know that dx is root 6 cosine theta d theta. So this is going to be times square root of 6 cosine of theta d theta. Okay, there is a little bit of cleanup that we can do. Okay. There's a square root of 6 and a square root of 6. So those clean up, right? And I'm going to go ahead and expand this or make it what it's supposed to be, right? So this is going to be equal to, right? Integral. There's a 1 on top, and it's going to be cosine theta d theta. So I'm just going to go ahead and put that on top. So it's going to be cosine of theta d theta divided by sine theta. And now I'm going to go ahead and put this all under the square root. Okay, actually, let me not end the square root yet. Square root of 6 squared, that is 6, right? Minus square root of 6 sine theta squared, that's going to be 6 sine theta squared. And now I'm going to sort of cut that off right there. Hopefully everybody saw that substitution there, right? Okay, let's keep going, right? Let's keep going. I'm going to put it over here, equal, right? Integral cosine of theta d theta all over sine theta. Everything in the square root has 6 in it, so I'm going to do this. I'm going to do square root of 6 times the square root. Make that a nicer square root of 1 minus sine squared theta. Okay, so now hopefully you guys see, here's where we're going to need that trig identity, right? So integral cosine of theta all over. I'm going to move the equal sign over a little bit. There's a 1 over square root of 6, so I'm going to do 1 over root 6 out front. Okay, sine theta, the square root of 1 minus sine squared theta, that's going to be the square root of cosine squared theta. So the square and the square root cancel. I get left with times cosine theta. Then I forgot a d theta on top. There we go. We're getting somewhere, right? Cosine theta cancels. And I get left with 1 over square root of 6 times the integral of 1, d theta over sine theta. Okay. And if you remember this from our previous section, right? This is 1 over root 6 times the integral of cosecant theta d theta. And the answer here, and actually, let me not do it over there. I'm going to do it over here because I'm going to need some more room down here. Is going to be 1 over square root of 6 times ln of cosecant theta minus cotangent theta. Okay, plus c. Okay, so Now, here comes a problem, right? Our original integral had x's in it, and our answer now has thetas in it, right? So we need to grab those thetas, right? All those, functions that we have there, and turn them back into x's, right? So therein lies a little bit of a sort of heavy introduction to maybe the tail end of our pre-calculus courses, right? So I need to get expressions for cosecant and cotangent that I can substitute in that'll make it all go back to x's, correct? All right. So the way that we do that is actually we go back to our initial substitution. So let me back up a second. Okay. I'm going to grab this and come down here. So if you take a look, x is equal to √6 sine theta, right? So then that means x divided by square root of 6 is equal to sine theta, right? So we are going to try to use this to get an expression for cosecant and cotangent. Okay, so cosecant is 1 over sine, right? So then therefore, because we have this, we have √6 over x is equal to 1 over sine of theta, and this is our cosecant of theta. So we have our expression for cosecant. I'm actually gonna theta. Okay, so this right here we have from here. Okay, now let's go ahead and look for cotangent. Okay, so again, we have sine theta is x over √6. We're going to try to find some way, because in order for us to get cotangent, we need cosine over sine. We have sine already, right? So we need cosine. So that's what we're looking for. So the way that we're going to do that is we're going to essentially use our identity, right? This the identity sine squared theta plus cosine squared theta is equal to 1. Okay. So if we take a look at this, right? Cosine, let me go back. If we solve for cosine, we should get something that looks like this, right? 1 minus sine squared theta. So this is what we're going to end up trying to construct here using this right here, right? So if x over √6 is equal to sine theta, right? Then if we square both sides, right, we have this. X squared over 6 is equal to sine squared theta, right? 1 minus x squared over 6 should be 1 minus sine squared theta. And this is equal to cosine squared theta, right? So then therefore, our final bit, the square root of 1 minus x squared over 6 should be cosine of theta, okay? So we have sine of theta. We now have cosine of theta. So then therefore, I'm going to move that over here. Cotangent of theta should be cosine of theta divided by sine of theta. We have cosine. 1 minus x squared over 6 divided by sine x over square root of 6. And if I clean this up a little bit, there's not much left for you to do here. You can maybe have square root of 6, square root of 1 minus x squared over 6 divided by x. That is as far as we can really go. right? So then now, our final answer is going to be 1 over square root 6. Continuing on from this line right here, it's going to be 1/6 times the ln of the cosecant, which we found to be root 6 over x, right? Minus cotangent, which we found here, be root 6 times the square root of 1 minus x squared over 6 divided by x plus c. We are done. These, like, remember I said, these are all highly long, convoluted, okay? You're gonna have tons of side work. So if you guys notice, all of this was side work, right? Okay, keep a track of everything. Don't be afraid to write anything down. Keep your thoughts straight, okay? Okay, let's try one more. Okay, so let's go ahead and take a look at this next example, okay? The square root of 2 minus x squared divided by 2x. We're going to do the exact same thing, okay? Since it has a 2 minus x squared, right? We're going to be using the same technique that we were using in the previous example, okay? So this one I'm going to rewrite, okay? It's going to be equal to the integral, right, of the square root of 2 squared minus x squared all over 2x dx, okay? And now that I have that rewrite, right, now that this sort of points out what my x substitution, my trigonometric substitution should be, right? So if you guys thought it out, my x should be equal to root 2 sine of theta, okay? Which means my dx should be root 2 cosine theta d theta. Okay, so now with this alone, right, we can go ahead and start doing our substitution here. Okay, and we're just going to go ahead and start plugging stuff in, right? So integral, it's going to be the square root, right? I'm actually not going to put the lid on it yet, of root 2 squared minus root 2 sine theta squared, and now I'm going to put the lid on it, all over sine, 2 times x, which is root 2 sine of theta, right, times my dx, which is root 2 cosine theta d theta. Okay, it's looking nasty already, but let's go ahead and keep going, right? So there's a root 2 out front. There's a root 2 on the bottom there, right? So I can reduce this, right, to be this. I'm going to do some of the math that's happening on the top here, okay? Integral, right? It's going to be root. Let me not put the lid on it yet. Let me start over. Integral. So it's going to be 2 times 1 minus sine squared theta, right? And now I'm going to put the lid on it, divided by 2 sine theta times cosine theta d theta. Okay, we're getting there. Okay, stuff is looking a little nicer, right? So let's keep going, right? Equal to integral. I'm going to have a root 2. So let me actually do this. It's going to be a root 2 out front, right? And then there's going to be a divided by 2 from the bottom. So it's going to be root 2 over 2 times the integral, right? It's going to be this 1 minus sine squared. That's cosine squared. And then we take the square root of that. So at the end, what we'll have is just cosine theta on top. Cosine of theta over sine of theta. Whoa, theta. Right? Times cosine of theta, so that this becomes squared d theta. Okay, so hopefully you guys see that all that trig that just happened, right? Okay, so now here is where we're going to use all the stuff that we did from before. Okay, so the square root of 2 over 2. I'm going to use my trig substitutions, right? Sorry, my trig integrals to do something with this, and hopefully reduce it down to something a little nicer, right? So integral, the cosine is 1 minus sine squared theta, right? All over sine of theta. And if you take a, and this is d theta, right? This reduces down to square root of 2 over 2. It's going to be the integral. And actually, let me put it in brackets here. Integral, right, of 1 over sine of theta. I'm going to put the d theta on top. Let me try it again. Integral of 1 over sine theta. I'm going to make this d theta, right? Minus the integral of sine theta d theta. So if you do all of this, right, it should reduce down to that, okay? So I'm skipping a couple steps, right? So I do expect you guys to sort of be able to fill in the blanks there, right? Now, what we have here, right? Let me rewrite it one more time. Root 2 over 2. This is going to be times the integral, right? 1 over sine is cosecant. Theta minus the d theta. Let me practice what I preach. D theta minus the integral of sine of theta d theta. Right? Okay, so then I'm going to go ahead and do both of these separately. Both of these are integrals we know how to handle now, right? So these two, right? The integral of cosecant, right, is, let me put the root 2 over 2 up front, okay? It's going to be the ln of cosecant of theta minus cotangent of theta, right? Plus cosine of theta, right? Plus c. Okay. So what we have here is almost everything, right? So all of our expression, if you guys remember, right, from the very beginning, our expression has got a bunch of x in it, right? X's in it. And right now, our answer, though all the math works out, right, has a bunch of thetas in it. So we need to sort of rectify that. We need to get rid of the thetas, replace back the x's, right? So that means we need to use that trig substitution that we did originally, right? So we need something, right? We need something that gets us all of this and something else that gets us just cosine theta, right? Okay, so now, to get these pieces, right, we're just going to try our best to try to construct our sines and cosines and then divide however we need to, right? So from here, we have x is equal to root 2 sine theta, so x over root 2 should be equal to sine of theta. We have our sine theta, right? So then therefore, right, we have 1 minus x squared over 2. This should be equal to 1 minus sine squared theta. right? Which means the square root, I'm going to go ahead and just next line, right? The square root of 1 minus x squared over 2 should be equal to cosine of theta, because this is cosine squared of theta. Okay, and we have everything we need now, right? Because we have, let me point this out, we have a sine and we have our cosine, right? And cosecant is 1 over sine, right? Cotangent is cosine over sine, and then cosine is just cosine. Boom, right? So all of this is now equal to root 2 over 2 times the ln. I'm going to put big parentheses there. Cosecant is 1 over sine, which means it's this thing flipped. So it's going to be ln of root 2 over x minus cotangent theta. So that's going to be cosine over sine. So this one divided by this one. Okay. So that's going to be square root 1 minus x squared over 2 divided by sine, so x over root 2, right? Plus cosine of theta, square root of 1 minus x squared over 2 plus c. Okay, and I mean, you can clean this up a little bit. Let me actually make this a little bit more legible. X squared over 2, square root of that. You can make this a little bit, you can clean it up, maybe get rid of some of the fractions, but it's not going to get any prettier than this. So this should be enough, unless your online system is asking you to sort of reduce it anymore. This should be enough. This should be enough. Okay. And we're done with this one. Okay. So what comes up next is, like I said, I want you guys to practice. Here's a couple for you guys to practice on. Okay. The evens do the one on the left, the odds do the one on the right. We're still using sign substitutions here. Okay. So just keep that in mind. Okay. Moving on. I want to go ahead and try to do this one. So a new combination, a squared plus x squared, right? It's similar to how we handled the one with the negative in it, right? But in this case, we're going to be using this trig substitution, the tan squared plus 1 is equal to secant. So if you take a look, right, we want our x, we want this thing, our x squared. We want that to be some version of tangent, okay? So let's go ahead, get started with the next one, right? So I'm going to go ahead and, again, I'm going to do a little bit of a rewrite, okay? And here's going to be the rewrite, okay? Integral 1 over, the x is going to stay. Everything inside of the square root is divisible by 4, so I'm going to do a square root of 4 times the square root of 1 plus 4x squared. And I'm going to put the dx on top. Okay, so now you guys can see it's this tail end that we're going to be manipulating, right? So let's go ahead and start doing that. If you guys are thinking ahead a little bit, that's good. We are going to let x equal. And the idea is we want something that looks like this, right? So some a squared plus x squared, right? We want some a squared plus x squared. And we want to turn it into something that looks like this, right? Tangent squared plus, or in this case, right, 1 plus tangent squared of theta, right? This is what we want to turn it into, really, okay? So in this case, our x is going to be 1/2 tangent theta, which means our dx is going to be 1, let me do it the other 1/2 secant squared theta. Okay, and we're off to the races. So let's go ahead and start substituting stuff in, right? So it's going to be integral. Okay. The square root of 4, actually, let me do that first. The square root of 4, right? That's 2. So there's going to be a 1/2 sitting outside times the integral. 1 over, I'll do the dx in a little bit. I'm going to do it over here. The x, right? 1/2 tangent theta times the square root. I'm not going to put the lid on it yet. 1 plus 4 times 1/2 tangent theta squared. Now I'm going to put the lid on it. There you go. That's all the bottom, right? Times dx, which we know is 1/2 secant squared theta. Okay. Oh, d theta. Okay. There's a 1/2 on the bottom, a 1/2 outside multiplied, right? So there's still going to be a 1/2 out here. So just keep that in mind, right? Let's go ahead and do some reducing here. 1/2 integral 1 over tangent theta times the square root. This thing in the parentheses, or sorry, in the square root, right? That's going to reduce to 1 plus tangent squared theta, right? And it's going to be, I'm going to just go ahead and do it on top here. I'm going to get rid of the 1. Oops, that's still an integral. So it's going to be secant squared theta d theta. I'm just grabbing the secant squared theta d theta, throwing it on top, right? Equal. What we have here, right, if you guys can see, 1 plus tangent squared theta should be equal to secant squared theta, and then the square root should get rid of the square. So this leaves us with 1/2 times the integral secant squared theta d theta all over tangent theta times secant theta. Okay, there's a square and 1 down below, so this secant cancels one of the top ones out. We get left with equal to 1/2 times the integral, right? Secant theta d theta divided by tangent theta, right? If you reduce this down, we're almost done. 1/2 times the integral, right? If you reduce this down, just the integrand of that last bit that I just did, that's going to reduce down to cosecant of theta d theta. And again, we know what this integral is, so it's going to be 1/2 ln, right? Cosecant theta minus cotangent theta plus c. Okay, so again, we need some version of expressions for cosecant and cotangent, so that means we need sine and cosines, right? Okay, so again, we're going to start with our original substitution, right? Since x is 1/2 tangent theta, right? Then that means 2x is equal to tangent theta, right? So from here, we know 1 over 2x should be 1 over tangent theta, which is cotangent theta. So we have an expression for our pink portion there. Okay. Now we need to do cotangent. Sorry, cosecant, right? So here is where we're going to use this one. There is an identity, right? Another identity, right? 1 plus cotangent squared of theta is equal to cosecant theta squared, right? It's another one of our Pythagorean theorems, right? So we get to go off on that one. So we know what cotangent is. We saw that, right? So cotangent squared, 1 plus cotangent squared is 1 plus 1 over 2x squared, right? Since cotangent is 1 over 2x. And this should be equal to cosecant squared theta. Therefore, our final, right, is the square root of 1 plus 1 over 2x squared should be equal to cosecant theta. We have the expression for our blue section, right? There's multiple ways to figure this out, right? I used an identity. I could have broke it down to sines and cosines. I could have used a triangle. Any which way you remember how to do this stuff from pre-calc works for me, okay? So our final answer, 1/2 integral, 1/2 ln, got a little confused there with my notes. My cosecant, square root of 1 plus 1 over 2x quantity squared, right? Minus cotangent, right? And cotangent's 1 over 2x. Plus C. And we are done. Simple enough, right? Kinda. Okay. Again, I want you guys to practice. So I'm giving you guys some quick checks that have the plus in them, just like the one up here. So give them a shot. Just make sure that your substitution, this is the crucial bit in all of these, right? Setting up the substitution, the trigonometric substitution, so you get the thing that you want, right? Okay. So go ahead, try these out. Okay. Moving on, there's one last one that I have to figure out. It's this one. I have to show you guys this one. X squared minus a squared. We're going to rely on the same identity from the one up above, right? But it's going to be flipped. Instead of tangent squared x plus 1 is equal to secant, we're going to subtract the -1 on both sides, and we get secant squared x minus 1 is equal to tangent. Okay. And the identity that we're going to try to play around with here, right, is this one at the end, this one. Okay. So this one is going to be pretty involved. There's a reason why I gave this page. There's a reason why I gave this example an entire page. It's because you will need an entire page here. Okay. This is going to be using like a lot of stuff from our trig class. Okay. So keep track of everything. Okay. I'll explain every step, and at the end, I'll sort of review everything, all the steps that we did, grossly, right? And explain some of the sort of like specific as we go. Okay. So the equation here, the integral here, right? Or the problem, it's saying find the area under the curve, that thing right there, over the interval -2 to -1. So we are looking for this area right here. So we know what we're looking for. This is a good old standard integral, right? So I gave you guys the integral calculator here, just in case you want to verify the answer, right? And I'll do that at the end as well, okay? So let's go ahead and get to it. We know that this answer here, right, should be the integral from -2 to -1, right, of 5 over, right, x squared minus 4x to the 3 halves, right? Okay, so I'm gonna do a rewrite, okay? The rewrite's gonna be the integral, -2 to -1. This one's gonna be long, so 5 over, it's gonna be the square root, right? X squared minus 4x, all of this to the 3rd, and I did put the dx on both of these dx. Okay, so now we have a square root thing, but you guys are probably looking at, I don't see this yet. I don't see that yet. So what we're gonna do, this is something that hopefully you picked up in pre-calc, right? The process that we're about to do is what's called completing the square, okay? I'm gonna essentially grab this, the x squared minus 4x, and I'm gonna turn it into something that looks like this right here, okay? So this is how we're gonna go ahead and do it. So I'm gonna do it over here on the right here, there we go. X squared minus 4x. This is equivalent to x squared minus 4x plus 4 minus 4. So if you take a look, I added 0, but I added a nice 0, okay? I added plus 4 minus 4, right? If you take a look at it, and there's a means to an end there, right? It turns out that that first portion turns out to be x minus 2 squared, and then minus 4. So what I have is this. This blue portion is the x minus 2 squared, and minus 4 is minus 4. It's very innocent looking, but it's going to help us, right? And all of this is now equal to x minus 2 squared minus 2 squared. So now look at what I have. Now I have an x squared minus something squared, right? Okay. So here we go. So now I'm going to use that. I'm going to use this this completed square, right, inside the square root here. So what I now have is this. This is going to be equal to the integral from -2 to -1 of 5 divided by, I'll put a square root here. Okay, it's going to be this thing. X minus 2 squared minus 4, whoops, minus 2 squared, minus 2 squared dx. Okay. Hopefully you guys see that. And let me, look at me go. I'm going to forget a cubed. So all of that thing on the bottom is still cubed, right? Okay. So now hopefully you guys see what we need to do here, okay? This substitution is a little bit confusing, okay? But if you take a look at it and look at what's going to happen at this point on, it works out. It works out. Okay, so the idea here is this. I'm going to let x minus 2, I need all of that to be equal to 2 secant of theta. Okay, and if I do that, then x is equal to 2 secant of theta plus 2, which means dx is equal to 2 secant theta tangent theta d theta, because that's the derivative of secant theta, right? Okay, we are off to the races. This is going to be the integral. Let me grab the 5, stick it out front, because I can do that. Let's go ahead and start doing this. The x minus 2 is going to be 2 secant theta, so it's going to be 1 divided by, I'm going to put the square root on the bottom, right? I'm not going to put the lid on it yet. 2 secant theta, quantity squared, minus 2 squared Now I'm going to put the lid on it. Cubed, right? And now I need the dx, which is this mess right here. So times 2 secant theta tangent theta d theta. Okay, let's go ahead and do some more simplifying here. The 5 stays outside. Integral. I'm going to go ahead and do some of the stuff that's inside the square root here, right? So 2 secant theta squared, that's going to be 4, right? 2 squared is 4. So I get to factor out a 4 from both of these, right? So I'm going to have this left, right? And I'm going to grab all of this just as a one fell swoop. I'm going to grab all of this that's on the tail end here, and I'm going to stick it on the top of my fraction. So it's going to be 2 secant theta tangent theta d theta divided by, let me put the line, make it a little straighter. It's going to be square root of 4, right, times the square root of secant squared theta minus 1, and this is still all cubed. Okay. Okay, let's keep going. Okay, the 2 and the 5, I'm going to combine those on the outside, and then I have a root 4, right? The root 4 is going to be 2, and that's being cubed, so that's going to pop out as well. So I'm going to get left with this, 10 over 2 cubed, right, times the integral. Secant theta tangent theta d theta all over, right? Secant squared minus 1, that's tangent squared. The square root of tangent squared, right, is just tangent, and then that's still being cubed. So what I get left with at the bottom, right, is going to be a tangent cubed of theta. Okay. I have a tangent on top that should cancel one of the ones on the bottom. This now reduces to 10 over 2 cubed. So 2 cubed is 8, times the integral of secant of theta d theta over tangent squared. Okay, let me do one more step. 10 over 8, that reduces to 5 over 4, right? And if you grab this, secant theta divided by tangent squared theta, right? You reduce down to, oh, too far. Okay, you reduce down to the integral. This thing right here is going to be cosine of theta divided by sine squared theta. Okay, and this right here is a good old U substitution. It's a good old U substitution. Okay, and then d theta. And your final answer, when you do U substitution for this, so I'm going to go ahead and do let U, right? U is going to be sine of theta, which means du, right, should be cosine theta d theta. And if you do all that out, you run through the algebra and the calculus for that, right? Your final answer should be negative 5 over 4. Whoops, equal negative 5 over 4 sine theta, right? Okay, again, go back up to the very beginning of the problem, right? Our function and our integral had x's in it, right? And our final answer down here has thetas in it. So we have to rectify that. We have to bring it back to the x's, right? Okay, and to do that, again, we're going to be using this thing. We're going to be using this to construct, we're going to use that to construct, in this case, we just need sine, right? We just need sine. So I'm going to grab this yellow one. I'm going to bring it down here. So if x minus 2 is equal to 2 secant theta, right? Then x minus 2 over 2, that should be equal to secant of theta. And secant of theta is 1 over cosine of theta, right? So then therefore, right, 2 over x minus 2, this should be equal to cosine theta. So we're getting closer, right? Since cosine is 2 divided by x minus 2, so in the previous examples, I've been using the trig identities, right? In this one, I'm going to go ahead and use the triangle. Okay, so if you guys remember from pre-calc, we can set up a triangle with this thing, right? So any which way you want to do it, it should get you the same answer. So let's say this is my angle theta, right? Cosine is adjacent over hypotenuse, right? So my adjacent is going to be 2. My hypotenuse is going to be x minus 2. So and if I solve this side, right? I'm going to solve this side. I'm going to call this b, right? So it should be b squared plus 2 squared should be equal to x minus 2 quantity squared, right? So b squared is x minus 2 squared minus 2 squared. B is going to be the square root minus 4. Okay, and if you remember, right, that thing is also the square root of x squared minus 4x. If you simplify it all down, right? So now we have this, and you guys are probably like, why do you do that? Cosine is adjacent over hypotenuse, right? We're going to use SOHCAHTOA to find sine. So if we look at sine, right, of theta, and this is my theta here, right? Sine is opposite over hypotenuse. So opposite is my newly found b divided by my hypotenuse. So I get the square root of x squared minus 4x over hypotenuse x minus 2. Okay, so now we have an expression for sine, right? So then I'm going to keep going here, equal negative 5 over 4, and I'm going to put in my newfangled thing here, square root x squared minus 4x over x minus 2. And if you now sort of clean this up a little bit more, you get minus 5x minus 2 divided by 4 times the square root of x squared minus 4x. And now, since we have undone completely the substitution for our thetas, for our trigonometric identities, right? We now can apply the original limits of integration. So now, this is now all evaluated from from negative 2 to negative 1. Okay? Almost done. So equal to, it's going to be the top one minus the bottom one, right? So it's going to be minus 5, minus 1 minus 2, minus 1 minus 2, all over 4 times the square root of minus 1 squared minus 4 minus 1 minus a minus 5 minus 2 minus 2 square root. Make sure you keep all your stuff in parentheses if you need it. Just keep track of all your numbers. This is like I said at the very beginning, this is a long problem. Okay, so there's going to be multiple spots where you're going to be making lots of mistakes, and they're going to be, just silly mistakes, really, that you just forgot to take a negative, or you turn a 4 into an 8 somehow, right? Just keep a track of everything, right? Okay, 12. This right here, let me rewrite this a little nicer. It looks sort of messy. 15 divided by 4 square root 5 minus 20 divided by 4 square root 12. Okay, so this is the final answer here. This one right here. Okay, that is the final answer. So like I said, what I wanted to do was I wanted to go ahead and show you guys how this is supposed to look like on your definite integral calculator, right? So I'm going to go ahead and plug all this in. We're going to just double check this answer that we did right here, right? So I'm going to do a double screen here. Don't mind the back end of my desktop there, nice and messy. Okay, so I get to take the integral of this thing, right? So I get to plug that in straight up, 5 divided by. Make sure you type everything in correctly. So x squared minus 4x, right? And then this is going to be to the 3 divided by 2. So that is my integral, okay? And I need it from -1 to negative, so from -2 to -1. So I can drag this thing to -2 to -1. There we go. So our answer should be this right here, 0.23367,531, right? That is that integral. You can take a look. I'm going to zoom in a little bit and there we go. Yeah. That is the section that we were looking for, right? If you guys take a look at it, it just doesn't look that pretty. It's sort of like a little zoomed out. There we go. Boom. Okay. So there's our shape. We did all this math and we got down to this point. This should be our answer. So I'm going to go ahead and just double check our answer here. It's going to be 15 divided by 4 square root of 5, right? Minus 20 divided by 4 square root of 12. And lo and behold, we got the right answer. We got the same answer. Okay. All right. So let me go ahead and open this up again. This one is a hard problem. And unfortunately, I have to break this to everybody. You guys are getting into parts of calculus where you're going to be taking, 2-3 pages with you. Okay. This is one of them. Okay. Look at all the math that I got to do, right? This used up every single bit of our calculus, right? And our pre-calculus course, because we were doing a bunch of trig identities over here on the left, right? And even some of our algebra, we had to do complete the square before we even started anything, right? Okay, so review this answer, review the work. This is probably one of the problems. I wouldn't give you something this long, right? So just keep that in mind, right? This is probably one of the hardest ones I'd probably give you, okay? I think after this, I am done because there should be lecture questions at the lecture questions after this, okay? So now that we are learning these techniques, right? You guys are going to be able to do much more varied integrals, right? That have to deal with previous section. So for example, find the surface area of the shape generated by f of x equals x squared. We weren't able to do this before, but now we are. Okay, and the reason why is because we needed trig identities to be able to do it. Okay, so go ahead, try these out. Okay, if you get stuck, drop me a line or come see me at my office hours. Or I still have my Friday hours if you guys want to drop by then. Okay, besides that, I believe I am done here. Happy studying.